Okay, I think we're going. Sorry, this is multiple attempts to record this video today. I'm on this really old computer in my office, and it had crashed with the screen recorder software I was using, so hopefully we will have more success now. We are back. We are working on Project 2. We're in grass, and if you're following along in the Project 2 file, we're going to cover Part 1 and Part 2 of the steps that you have to complete for the project. So we are going to do a basic terrain analysis as we talked about on Monday, and then we're going to do some SQL querying like we did in Project 1 to extract a set of sites to work with throughout this Project 2 and also probably potentially Project 3. Before we get going on all of this, I want to point out one particular issue that especially Windows users might run into with the sample data. When you start it up for the first time and you try and add the the Project 2 grass data folder and you try and get into permanent, you may have a problem kind of doing that. And, depending on how it pops up, if it pops up like this, it says somebody's already using this, then you can switch to selected map set, and that should solve the problem. However, I have seen at least one student have an error that pops up in the bottom right. And to solve that, there's a little text file called a .gis lock file that gets put into the map set when somebody is in current use of it. This is a holdover from the history of grass, but very simply to remove it, what you'll do is navigate to your grass data folder in Project 2, and then go down into the map set. In this case, it will be permanent, and find the .gis lock file. On my system, I have to hit show hidden files, but you may not have to do that. And it is this one right here. You can just delete that. Either right-click and send to trash, or you just hit the delete key to get it off your system. And it will not cause any problem. It's just to prevent concurrent use with two users reading and writing the same data, which would be a problem if you were working on a server or on a mainframe or something like that, but you're not doing that, so it's not a big deal. So you can feel free to manually do that. Normally I don't send you down into these files, because if you delete any of these other things you could have problems, but this particular one you can delete with no issue, and it will solve that problem. Okay. Now, since I've already tried to do this tutorial a couple times, I've made a bunch of the maps, but I'm going to go through it again and show you how to do it. So I already made a new map set called terrain analysis, and I did it by right-clicking on the location, hitting create map set, and typing the name into here. So I typed in terrain analysis and hit OK. And it created this new map set. And I've made a bunch of maps in there because, again, I've already gone through the tutorial. But what you want to do is to right-click on the new map set and switch into it if it hasn't done that already. It may do that as you create the new one. You'll know you're in the correct map set because it says current. And what we're going to do is follow along with the basics of the terrain analysis that was in the lecture on Monday, and the steps 1, 2, and 3 in part 1 of the project file. And the first thing is to get a visual qualitative understanding of the topography. So in the permanent file we have the SRTM. We want to make at first a hillshade, which is again a pseudo 3D. It's more of an optical illusion to make the terrain pop. So we've got the patterns with colors, but let's do it with this shadow values that we can actually see what's going on. So remember, we're in terrain analysis map set. All the new maps will be made in this particular one. All of the terrain analysis modules in grass are conveniently located under terrain analysis. We also have hydrologic modeling, which we will cover today as well. So starting in terrain analysis, we are going to find the shaded relief r.relief, compute shaded relief module. This takes the SRTM, and what I will show you, I'm just going to overwrite the hillshades that I've previously made. You can call it HASA 30-meter hillshade. You can edit exactly where you want the sun position. Remember, it's creating shadows using the topography to calculate where the shadow would fall if the sun was in a particular position. The defaults are good enough, but if you have a particular day of a particular season, a particular time, you can put in the values of where the sun would be and get those kinds of shadows. I'm going to click this Allow Overwrite. And again, remember, this is where you got to have caution because, you want to make sure that you're not doing this. And we're doing a factor of 1 for the vertical relief, exaggerating the relief. So if I hit Run, it will chug along and produce that hill shade. In my case, it overwrote the one with that I had done before. And now you can see this is a flat map, and it's in grayscale values. It's got numbers, but the numbers don't really mean anything other than how deep the shadow is if the sun was at that particular position shining on this particular topography. To exaggerate that, you can, under the Optional tab, change the factor for exaggerating relief 2 or maybe 3 times. Now I've already created those, so I'm just going to add them here. This is 2x and this is 3x. And basically what you can see is the shadows are getting deeper, or they're looking deeper, because it's basically pretending the mountains are 2 or 3 times as tall as they actually are. Now, that's great just to see it in black and white, but you may want to drape color over it. And I'm going to show you that after I show you how to create some of those secondary derivations from topography like slope and aspect. In terrain analysis, we're going to find the r.slope.aspect, slope and aspect, and this is also where you will create your curvatures. Again, everything here is starting with elevations, derivations of elevation and topography. So required, you pick that. For the outputs, you just put in names that are sensible. It can be just slope, could be Hasse slope, something like that. So you'll do slope map, you'll do an aspect map, you'll do the profile curvature, and I tend to call it PC. Tangential curvature I tend to call TC. And then here is where you can customize this. So remember I said slope could be either in degrees, which is standard for GIS stuff, or percent grade, if you really know you want that. You can also make the slope and aspect maps be integer values by selecting cell, or even get more precision by selecting D cell if you wanted, but F cell is fine. That's just like a certain number of decimal places. You probably don't have to worry about these. You can leave these as default, but remember, everything has a manual page, so if you really want to know what those are, you can read about them in the manual page. And then you could also check this box here that says create aspect as degrees clockwise from north, like a compass. By default, it does clockwise from east. If you are going to take the aspect and put it into another GIS routine in GRASS, you should not check this box, because most of them want the aspect as 0 is east, right? That's just the way GRASS always calculated it. But for your interpretability, if you really want to know like what direction of the compass I'm facing, you can check that box and then you can hit run. Now I've already created these, so I'm going to hit the overwrite just so you can see what happens and what it looks like. It'll do it real quick, and boom, all the maps will be made behind you. The values for curvature, if we put them, the raster legend up, let me just quickly style this map so that we can see it with the background on, and click OK. And then I'm just going to resize and move it to the upper corner. Yay big. So you can see 0 is no curvature, and then we have convex and concave curvatures. This one I think is for TC. So again, this is the horizontal curvature perpendicular to the direction of slope, and then the vertical curvature in the direction of slope is the PC. And if I was to change the input for that, you'll see the values shift a little bit, but they're basically the same deal, where 0 is no curvatures, and then you have convex and concave curvatures as well. And then we have aspect, and if I put that up into the scale, we can see that, well, there's a bunch of weird minus values over here in the flat areas, but it would be 0 to 360. And then the last one made was slope, and if we add that instead, to the scale bar, we can see that we have, in this area, the maximum slope is 72, the minimum slope is 0, and all these sort of pinks and reds are high slope areas, the sort of cyans and blues are mid slopes, and the greens and yellows are low slope values. Let's see what this looks like when we drape it over our hillshade map. To do that, instead of the normal add raster, we go to the add various rasters, and we click on the shaded relief map layer, add shaded relief map layer. We get d.shade. First option is to pick our hillshade, and I'm going to pick the no exaggerated relief version first. Then the color, the drape map is the color map. I'm going to pick slope, and I'm going to hit apply because the first thing will be a little dark, right? The first view of it. But you can already see that this is popping a little bit more in pseudo 3D to you. On the optional tab, there is a percentage to brighten. I usually start with about 30%, and you can see it already looks a little bit better. And often I have to crank it up to around 40%, looking a little bit better. And if I go more than that, it might be like too bright, which to me that's looking a little too bright. So I'm actually going to go to about 35% for this particular map. That's looking pretty good. So here we have our slope values, the colors that go with the scale bar, draped over the shadow values of the hillshade. And if we zoom into a place with lots of relief, we can kind of see how that's helping all this pop to our eyes in 3D. Now, that's the 1x hillshade. Let's get in that like super exaggerated 3 times 1, and we can see that really helps to pop out the relief a little bit. And if we zoom out, we can really start to see that our brain is really interpreting that as a 3D view of the map. Let's go ahead and put on a different color just so we can see. Let's pick our profile curvatures, and probably need to zoom in on this a little bit to see the difference. But now we can really start to see those convex ones are in the red, and the concave curvatures are in the blue. Okay, so yeah, pretty cool. While we're at it, what I'm going to do is I'm going to just, since we're zoomed in, I'm going to zoom back out to cover the whole map. I'm going to remove, I'm going to remove the legend, and I'm going to show you how to show the full 3D, real true 3D viewing. Now, it's really important that you uncheck any other thing or remove any other maps from this layer manager and leave only the map or maps that you want to see in 3D. What we'll do is just leave the SRTM for now, and then we'll go up to here where it says 2D view, and we'll click on 3D view. Now, this particular computer, for whatever, has some issues sometimes with my 3D display. I think it has to do with my graphics card on this crappy computer in my office. But on your computer, everything should render pretty nicely. At first, the first thing you'll see is this very low resolution, barely visible topography. And by default, it renders at a coarser resolution than the native 30 meters, just because it doesn't know how strong your graphics card is in your computer. Over here we have the View tab in the bottom, and we're basically, as you can see how bad it renders on my computer, which I apologize for, we're basically like in a helicopter, and this little dot is the helicopter. The closer the dot is to the middle, the closer we are to the center of the map. The further away it is, the sort of further away we are. And then this is the compass degrees, so we can kind of fly around and look down at the landscape from whatever direction we want to look at. So let's try and put it basically as due west as we can. And then we can change the height a little bit from this height tab here. Now, you may need to drag over some of these things so that you can see more of this interface in single window mode. We also have this kind of zoom, which is a little bit about like the focal length of the camera that you're using. And then we have a tilt, which we generally don't want to mess with too much, so we can reset all of these things also by putting values in there and hitting enter. And we also have a couple tools here so that we can recenter that, and we can actually tell it specifically to center a particular place where we click. And we can reset everything to the original views, or look directly from the top, look directly at the center, and zoom ourselves out as we want from that. Okay, let me just get back to a nice little view here, and there we go. Okay, so now why is it still all super blurry? Well, we have to go to the Data tab and up the resolution. So we have two draw modes. When you're not moving, you're in fine mode. When you're moving, you're in coarse mode. Although you, for whatever reason, can choose which one you want to look at. So here we have the resolution. Right now it's 6, so it's basically coarsening up by 6. So let's click down to 1. And now we have, well, again, on my monitor, this is not looking really good. We can, oh, sorry, I forgot that you can also, I hit my mouse wheel, and you will zoom in if you do that. So you can also use these things to drag them around. And again, on this computer, it's a real pain for me. So there's all kinds of weird modes. There's this mode where you can like rotate it around. Some of them are harder to view than others. This is like an airplane mode where you can fly. Again, if you get screwed up, go back to the view panel, hit reset. It will go back to the start, and then you can get yourself back looking the way that you want. And if we want, we can change the display to like the coarse, and I set it to wireframe. On your computer, that might look kind of cool, or for whatever purposes you want. We can change it back to the surface, and you can again increase the resolution. So this is actually finally displaying kind of right here. This is what you should be looking at, something like this. Now my problem is if I try and move this around now, because as I move it, it will try and display it in coarse mode. So if I set the resolution to 1 in coarse mode, my graphics card is really going to struggle with that. So I'm going to leave the viewpoint here. You can mess around with some of these tools to get that right. One other thing that you can do is click the appearance panel, and you can move the sun. So now this dot is actually the sun, and you can pull the shadows in any directions that you want. You can even make them be kind of like not the way the sun would normally shine. And of course you can change how high the sun is. So you can mess around with this until you get the shadows really nice. You want it to be more like noon, flat light, you can do that. And if you want it to be like early evening or early morning, you can do either of these two things. So again, this is more like evening, setting in the west, and this over here is more like morning, rising in the east. And depending on your scene, which way it's facing, one or more of these might be the better way to do it here. I'm going to go kind of like something that might never really happen, which is a long shadow at midday, or a little bit before midday. And then towards the bottom, we have the brightness, which you can kind of turn down, and the ambient light, which kind of evens out the light a little bit. So you can mess around with that till you get what you want. You can also set the background color to anything that you want. It might be nice to, oh sorry, that's the color of the light that I just clicked on. Set that back to white, like so. And then where is the background color? I think it's maybe, hold on a second, decorations. These are the arrows. We don't want that right now. Maybe I set that back in here. Somewhere in here you can set the background color. Again, you'll notice I kind of don't do the 3D view that much. Oh, here it is, background color. It's on the View tab. So let's set the background color to black, which often really helps pop everything out for you. Back on the Appearance tab, we can add like north arrows and scale bars. Since our background is black, I'm going to set them to white. And you can set the scale bar length in map units. Let's just make it be a kilometer. And then I'm going to click the Place New Scale Bar and put it off here to the side, like so. or maybe I'll put it here so we can actually see it. And then the same thing with the north arrow. I don't know why it's not putting it in. I'll try and stick it over here. So north is that way. There we go. Probably want to stick it a little higher up. There we go. Okay. You can also do some cutting planes with only one map in here. It doesn't make a lot of sense, but you can actually stack maps, separating them and filling between them, and do cutting planes to look at profiles. But you know, if you wanted to, you can set the cutting plane as such and move it around the map using these tools over here. But I'm going to turn it off because it's not particularly useful for what we're doing now. Okay, back on the data tab, what we have is right now by default we bring in the SRTM. It'll also bring in the color, but we can go down here to where it says color and it says map or constant. So we could just make it be any one color that we wanted to, but it's probably more useful to pick a different map to drape over it. So let's go ahead and pick our slope map, and there we go. We have it now showing here the colors from the slope map over the 3D of the terrain that we got from our SRTM. On the View tab, we can also set the vertical exaggeration just like we did for the hillshade. So we can go up to 2 or 3, and if I re-render this, there we go. We may need to actually crank our height down so that we get the view kind of back the way we expect it. Again, I'm telling you, I went a little bit too far here. My graphics card in this particular computer is really terrible. So we are now kind of really popping the vertical exaggeration, and the slope colors may be a little bit weird to look at. So let's go ahead and put the let's go ahead and put it back to the SRTM colors, and now you can really get a qualitative sense of what the topography is like. Now, I'm not going to do it, but you can use some of these tools to like really kind of get in there, almost like VR, and work your way around. If you want to save this out to a display, to a graphics file, click on this button right here, click OK, and a little dialog will pop out, and it will let you save it out to a TIFF file, and then you can navigate to that in your file browser. Mine's probably in here somewhere, like so, and here it is. You know, exactly what you were looking at gets saved out to a graphics file. Now you would want to take a little bit more care to style that before you saved it, okay? Alright, so I'm going to go back to the 2D view, which this computer does a lot better with. And from here on out, when I want to show this, I'm really going to use hillshades, and they're useful because they're real still plan view. The 3D views, the perspective views, are definitely more qualitative. It's harder to measure stuff on them, but they are useful for displaying what it's like in an area for sure. Alright, so we did our initial slope aspect. We got the slope, the aspect, the profile curvature, the tangential curvature. Let's get our landforms map. We'll go back to our terrain analysis, and we'll go to landforms, our geomorphon. Here again, we are going to input the where are we at? The SRTM, and you can read the manual for this a little bit if you really want to know how it's doing this. You know, it's got quite a good manual, but this is a really well characterized routine looking at those derivatives of topography to classify different types of landforms based on the curvatures and the slopes and all of those kinds of things, right? So this particular graphic right here shows you what the different geomorphons are. Now we'll get a classification and it will say something like slope or ridge or something like that, but really what it's doing is looking at shape, and it's doing it at a particular spatial scale. It needs at least a 3x3 window, so the center pixel is going to be encoded, but it's going to be done at that 3x3 resolution. Since our topography is 30 meters, that means the geomorphons, if we leave this 3, is going to be at the 90-meter horizontal resolution. Okay, you can leave the rest of these by default, but the output map that we're interested in is the common geomorphic patterns, and I just called that geomorphons, and I would have to hit overwrite to overwrite it, but you won't have to do that. Just so hit run, and you will get the map of the geomorphons, which looks like this. And if we add the scale back, the legend back, let's turn the background on, and then resize it over there, like about that big. You can see these are the colors, and if I zoom in, you will notice, right, that we got a lot of it at the 3x3. We're doing it at that 90-meter scale, but it is encoding at the 30-meter resolution. We can run again our geomorphons at a bigger horizontal resolution. Again, these have to be odd values, so I'd pick 9, and we would get a map that looks like this. And we would get maybe a better characterization of the landscape for the scale that we're interested in. Now, I got them stacked over here, so I can flash back and forth them here. But Grass actually has a map swipe tool under the file, GUI map swipe, in which we can load up our two maps. So we have the 9x9 because it's already highlighted. It's there on the left. And on the right, we can pick the 3x3, and then we can hit OK. And now we've got them side by side, and essentially it's like they're stacked, and I'm like moving the windshield wiper back and forth across them. And you can zoom into any particular part of the landscape and swipe it. So this is a really useful tool for exploring the differences between two maps. It could be two similar maps at different scale, but it could be something like a satellite image and a hillshade, and you can kind of swipe back and forth between them to get a real sense of how that looks. Okay, so that's a useful tool to look at as well. But also you can just go ahead and drape your geomorphons color map over the hillshade, and you'll get that pseudo 3D kind of popping out, and you'll really start to see, oh, that's what it means by ridge. Oh, that's what it means by valley. All right? Cool. One last set of analyses is going to take place, terrain analyses are going to take place using the hydrological modeling tools. So the first one we're going to use is the sort of Swiss Army knife of them, which is our watershed, the watershed analysis. And again, you only need the SRTM DEM as the input. And you can have these optional inputs, but these are for specialized use cases. With DEM, you can create pretty much everything you want here. We're going to make three outputs from this. We're going to have flow accumulation, which I call flow AC, ACC. We're going to have a flow direction map, flow dir, and then we are going to have a output basins map, which I'll call W-shed basins. To get the watershed basins, we need to enter in a special number of the size, the horizontal size that we want to deal with. Let's start with 1,000, and we also want to make sure that we're giving it lots of RAM over here. And then the other thing we can do is, well, I would have to select this, but we would select this positive flow accumulation. This means that anywhere that water might be flowing from off map, it would identify as negative, so you can discount them in further analyses. But for now, let's just do that so that it's not too confusing for you when I put the legend up here in the corner. So we'll hit run. Oops, this is the wrong value. Sorry. We need to put that in. Where is it? Threshold. Right here is where we put that in, 1,000. Sorry. Then we hit run. Okay, so firstly we have the basins at the 1,000 meter scale. That's a lot of small basins. Now we have the flow direction. This is where the water is heading from one cell to the next. It looks a lot like aspect. And here we have the flow accumulation value. So here is where I am going to put on our legend for the flow accumulation, and I'll click OK, and it'll look all black because, again, this is exponential. So now we need to, under the advanced, click use logarithmic scale, and it will stretch that scale bar so that we can actually see where the low values are. So now we can see, if we zoom in to a part of the map, all the yellow values are the ridges and upslopes. As it starts to be green, water is converging. As it starts to get into the cyans and lighter blues, we're getting rills, gullies, and little streams. And then anything black, dark blue or black, is a real big stream. And if I put that into the hillshade, if I put in the flow ACC, we really can see how that maps onto the topography. What you should do is experiment a little bit with, where's my watersheds? It's over here. Experiment with this value here until you get basins that are the size that you want them to be. I did this earlier, and so I have found that the value of 1,500 created basins that were meaningful when I put on my sites. I can actually start to see how these sites, let me just quickly style them a little bit nicer, like so. Put the colors to red over here. I can start to see how some of these basins are influencing the clustering of the sites. Part of this might be with the survey design of how the Wadi Halsa survey team worked, but part of it might be real, right? So this is kind of an interesting thing to start to look at. So if I was to put the big basins, the 1,500 basins, into the hillshade, I can really see how those watershed boundaries, right, map onto the terrain, for sure. Okay, so one other thing that we want to do is to extract some streams. So we're going to go to hydrological modeling, and we're going to click this extraction of stream networks, R stream extract. Now you can run this on its own with just the SRTM, and again, this is the same kind of value, the minimum threshold. I think 1,000 is going to work better for this because we want maybe smaller scale streams than we want for the full basins. But if we had a flow accumulation map already made, we could put it here and maybe it would speed things up. So let's go ahead and do that. Or maybe we had a flow accumulation made from a different routine than watersheds that we think is more accurate. We could put it in here and it would speed things up or make it follow that water pathway more than another one. Now we could have raster map of streams, but more useful is going to be streams. And it looks like 5,000 is what I stopped at last time, so let's go to 1,000. And then we could also output a flow direction map from this if we want. So it can do some of the same things that our watershed can do. I'm going to give this some more memory just to make sure that it can go ahead and do that. And one thing that you might do, once you get really deep streams, you might want to change to this single flow direction so it doesn't root water like up the side of the hill slope a little bit. And you can probably put in something like 10,000 here, and that should be enough. I mean, you look at this guide over here, somewhere around there is probably good enough. So we'll hit run. You'll just get better quality, deep, real streams at the end of it. Okay, so let's make it a little easier to see what we're looking at by taking away the hillshade. But yeah, here are the streams, and it also gives us a point for where each stream initiates and where it intersects with another stream. We want to kind of turn that off in the visualization of it, so in dvect for that, we'll go to the selection tab and we'll just uncheck point, and it will only show the streams here. And if we want, we can style this. We can make the lines like a little thicker, and maybe we'll make the actual color blue like that, and we'll get our nice kind of blue streams. And we can actually now see the pattern of the sites on the watershed boundaries with the streams. Let me move that underneath here and turn on the watersheds themselves and the streams in and around them like so. Really cool. Okay, one last thing that I want to show you about watersheds. If we wanted to, we have another module that we can use called it's like our water outlet. That's the one here. And here we can give it a particular XY coordinate and it will find the basin that is upstream from that, which is useful if you want to isolate just one particular basin. So to get the coordinate to start, get your flow accumulation map up. I'm going to push this over to the side. Get your query tool and find the area that you want to be where you look upstream from. So I'm gonna zoom in to this little bit right here, and I'm gonna query right here. And now I have my coordinate right here, and I can copy that coordinate, and in our water outlet, we're going to input the drainage direction map that we made with our watershed, which is flow dir. We're going to give this the output basin. So I'm just going to small central basin. And here I'm going to right click and paste those coordinates in. And shouldn't have to do anything else. It will run rather quickly. And it should delineate that basin. So let's see where that is. So if I zoom back out, let's just zoom out to the total map, it found just that little basin right there, upstream from the point we were looking at. Now you can see how this can be pretty useful for delineating one watershed, and irregardless of this particular scale of watersheds, you just want whatever's upstream from this point. This tool will find that for you. So if I put my coordinate here, it will get the entire Wadi Hassa watershed. If I put my coordinate here, it will just get this little valley. Right? It's a very, very useful tool to be able to do that kind of a thing. Okay. Now we are going to switch gears a little bit. We've done our basic terrain analysis and our hydrological analysis. Let's go ahead and show you how to query out a sample of sites from the big Wadi Hassa survey that we can analyze the values of these new terrain derivative maps that we've created. And we can analyze the values of those variables at the locations of these sites to understand what people might have been looking for or looking at when they were deciding how to put their sites or where to put their sites on the landscape in the most optimal way. So, the first thing we're going to do is in our Wadi Hassa sites map in here, we're going to right click it and click show attribute table. There are other ways of getting into an interface where we can do an SQL query, an attribute query. For example, we could go to the database query v.db select tool, and we could enter in some stuff there. We also have the SQL statement over here, which we could enter. But this one gives us a nice graphical interface, because right here we see the SQL query. We have the simple one where we can just quickly grab a column and put a value over here and query it out that way. So if I knew the site type that I wanted, I could just type it here, tower, and I can hit apply and it will query it out like that. But let us clear that and click on the second tab that says builder. Now I could type in, if I know my SQL, I can just type it in here. But let's click on this SQL builder, and then we get a little calculator. This is very similar to the one that we saw in QGIS. So we can do exactly what we did in QGIS. Select all, this is what the star means, from Wadi Hassa sites, and then we're going to use the where clause, and we're gonna go by site type. So we're gonna double click where that equals, and we're gonna grab our values and find the type of site that we want. Now here is where you can start to customize your project too. You can choose any type of site that you want. If you want to follow me, I'm going to use the example of tower sites. So I've hit apply now. I have queried all the tower sites. And I could go along with this, but we also have all these other columns that are temporal periods. Now, having done work in the area and knowing something about this, I'll note that most of the towers are either going to be from the Nabatean period or the Roman period, because they're the ones who built a lot of towers. So if we go back to the SQL builder and we rebuild our query so that we have site type equals, let me just make this bigger so that we don't run out of space, equals tower, then we can put an and. So this is again another logical conditional, Boolean conditional, and we can go all the way down to the NAB, which stands for Nabatean, equals, and if I get the values, it's either 0 or 1, yes or no. So now we have select all the sites from Wadi Hassa sites where the site type equals tower and Nabatean equals 1, yes. Okay, we hit apply. And now we have selected just the Nabatean tower sites, just the tower sites from the Nabatean period, and they'll be shown in yellow on our map. To make this permanent, we right click and we hit extract selected features and we create a new map which we can call Nabatean towers. Now I've already done this, so if I click OK, it says do you want to overwrite it? It will not say that for you. So click yes. And you can close this query tool now, and we can actually start to clean up our all of our maps over here. So I'm just going to click on one, hold the shift key, and click on the bottom one I want to hit to select, and then I'm going to remove. Yes. I'm going to remove these ones, and if I hold the control, I can click on them sort of independently. So I want to get rid of all of these ones here. Yes, and here's my Nabatean towers, and now I got to restyle them. So I'm just back into dvect. I'm gonna pick. Let's be fun and pick the plus sign, and give me some colors that I like so, blue and red, and let's make this a little bit bigger so that we can see them. Oops, there we go. Oh, actually, I don't like the pluses, so I'm going to quickly change them. Actually, what I'm going to do is change the blue on the inside to something like yellow. Okay, that's a little bit better. Maybe not the best choice, but it will do for now. So now we have all of our Nabatean towers, and if we get our hill shade back up, and let's go ahead and put something in like the geomorphons 9x9. We can really start to see, if I zoom in on an area, that, you know, each of these sites, where did they go? Oh, they're small now. I guess red and yellow wasn't good for displaying on top of a map that is also red and yellow. So I'm just going to click black and black and be a little bit boring, but okay. And it looks like I'm going to have to make them bigger too. Something like 21. Okay, there we go. So now we can actually see them on this particular map, and we can see that they are located on ridges, and we can even kind of visually see that maybe the landform is going to be whatever red is. So let me quickly grab my geomorphons again. Yeah, that's fine. Ridges and shoulders, right? That's kind of where they're located, which is interesting. Okay. Now what we're going to do, we have queried out our Nabatean towers. Let's do a little bit more of those like distance analyses, but in particular we're going to get distances between each tower and its nearest tower, because that could be a really interesting variable, and then also between each tower and the nearest stream. So to do that, we are going to go to the vector tools. We're going to go to nearest features, v distance. Let's first do each tower to the nearest tower. And what we're going to do is we have a from and a to. Because we're staying within the same file, we're going to pick the Nabatean towers for both of these. So Nabatean towers, from, Nabatean towers, to. On the from tab, these are point to point, so we'll just click, we'll make sure only points are clicked. And we'll check the mark that says minimum distance to nearest feature. And over here we can also do that, just make sure that we're doing point to point. And then the optional tab, we need to set the minimum distance to be greater than 0, because if we don't change it, the nearest tower is going to be myself, the tower that I'm at. So I got to put at least something like 0.01, so we'll find the next nearest tower, one that's not myself. As of right now, we can just look at this to see if this is giving what we want by hitting print output to standard output. And it will give us a rundown. It's got the category of the from and the distance to whichever one is the nearest one. So if we're happy with that, we can go back in here and uncheck the print output to standard out, and go to the from tab and create a column that we want to put this in. Nearest tower. And if we hit run, it's going to say, oh, we didn't find the column in the attribute table. Well, we can add that in. So right click on Nabatean towers, show attribute data, and yeah, sure enough, there's in here, there's a bunch of other columns, but there isn't one called nearest tower. So we're going to have to create that. Click on the Manage Tables tab, and here we can add columns of any type. Here we can type in nearest tower. Of course, it helps if I spell it right. Nearest tower. And we're going to change that to double so that we get all the decimal points. And we hit add. And since we know we're going to be looking for nearest stream, let's go ahead and add that as well. Nearest M. Nearest, I don't know what is going on. Maybe my keyboard is broken. The M. Okay, whatever. Here we go. We added that too. While we're at it, we have a whole bunch of these time period columns that we no longer need because we've queried out just Nabatean sites. So click on the ABBF, which is Abbasid Fatimid, and then hold the Shift key and go all the way down to UNK for unknown. You'll highlight all of these columns, right click, drop selected column. This is again is a warning because you cannot come back from this, right? So be sure you're only deleting the ones that you really want. You can't bring them back in once you do this. And now it's going to take a while to delete all of that stuff. But basically, we have created those two blank columns and we have deleted all the columns with data that we don't care about. So that's going to chunk away over here off screen. And in the meantime, we can try to rerun our v distance, and now it will do it, and we can go into the attribute table and we can look at that the values have been put into our nearest tower column right here. We've got all those data in there. Coming back to v distance, in the to tab, let's go ahead and select our 1000 streams, uncheck point, check line. On the from tab, we're going to want to pick our new column. It may not show up in there, so we have to type it in, unless you want to close this window and reopen it so they can read the new names. Nearest street is what, what my computer let me do. So that is going to do that. And we can hit refresh over here, and there they are in the values right there. Cool. What about all those other maps that we made? Well, we can upload them by querying, spatial querying. So here we go to update attributes and down to where it says sample raster maps at point locations, v.what.rast. Here, because we have our Nabatean towers highlighted, it fills it in for us, and we can pick whichever map that we want. and we can just go through each one. So first let's start with slope. And then on the optional tab, the attribute column. Here, for whatever reason, this one will create the column if it doesn't exist. Unfortunately, the v distance doesn't do that, but this one does. So here it's a little bit easier. All we have to do is hit slope, and we hit run. And just to show you that that's working, go back into the attribute table, and we can scroll on over, and now we have slope column, and the slope at the location of those sites is uploaded. If we wanted to, we could interpolate it in a neighborhood, but for now, let's just go ahead with this. So all you're going to do here is chunk through every single parameter that we created in the terrain analysis. Slope, aspect, profile curvature, tangential curvature, flow accumulation, basins, and geomorphons, 9 by 9. Okay, so you just do that. You go in here, you make the name for the new. That's so weird. I have a hotkey. M is set to a hotkey. Okay, so I can't type in M. Oh God, I hope it didn't erase the last little bit of what I was saying. Geomorphons. Unfortunately, I can't use the M key, so I'm just going to put landforms, but without an M. This is my new screen recorder. I just figured that out. What a fun thing. So we would hit run, and it would upload it. So you're going to go ahead and do that for all of those terrains, and you will see the new columns added as you go. Now, we can do a couple things here. We can get some stats for each column with our v.univar. And here we just pick the column that we want. Let's go ahead and put slope and click the extended statistics and hit run. And you get all those values that we talked about. The average slope is 8.364. The standard deviation is plus or minus 6. And you can get the maximum and the minimum slope value in your point set. You can do this for column by column by column. You can also export the attribute table. Where is it? It says export attribute table. And you make sure that this Nabatean Towers vector map is selected. You hit browse, and you input, you put an output. Sorry, let's go to our more sensible place, project 2. And then you can select, or you can type in the name of a CSV, a comma separated value, and under the format, select CSV here. And you may also have to select comma as the field separator, hit run, and it will write out that CSV file. And then if you go into your project 2 folder, you'll find that, and you should be able to open it up with your spreadsheet. In my case, it's LibreOffice Calc, but it could be Excel, or it could be Google Sheets if you wanted to open it up that way. It's going to take me a second here because LibreOffice, again, on my crappy office computer is running slow. So there it is. So it should, if you've done it right, say, figure out where the thing is. But it may be that it has this pipe value instead of the commas if you didn't do it. So you have to tell it that the separator is whatever symbol that you're seeing here for the columns. And then it opens up just like any other spreadsheet, and you can do whatever you want into it. In particular, what you might be able to do is highlight all of the data in a column. Excel, I think, also has this data statistics, descriptive statistics. Tell it where you want to put the results in, and it will calculate all of those same values, the mean, standard deviation, the sum, all of those things. It'll calculate them for you here. And you can also make a chart, for example. In our case here, we'll just make a bar chart of all the different distances to the nearest tower site. and it creates a chart like so. So each of these bars is one of our Nabatean towers, and the height of the bar is the distance to the nearest site. So it gives you a visual approximation of the spread of the data files. And you can do this for each column as you want, and following whatever software you're using, you can save it out as an image. Use that in your report if you like. There is a way to create this kind of plot from within GRASS, but I don't want to save that. But to do so, you have to install an add-on. And we've gone long, but I will show that here in case you want to do that. So you go to Settings, Add-on Extensions, Install Extensions from Add-ons, G extension. And this particular one is under the vectors. I'll just make this a little bigger so we can see it. And it is, what's it called? V histogram. You click Install, and it'll go ahead and install it. You'll see it crunking along. I already have it installed over here. So if I go to my tool menu and I go to add-ons, I can actually see it right down here. You would have to restart GRASS to see it in this menu, but you can always type it into the console. But vhistogram is an add-on module, and here I can pick my Nabatean towers. I can pick my nearest tower, for example, and go ahead and just hit, you can change the number of bins here. A histogram is slightly different than a bar chart. We can talk about this in class. Let's just set it to 10 for now. It's going to categorize 10 classes of distances of towers and show those, the spread of those in the data set. Hit run and pop up this. Now, if you're on Windows, this may not work, but if you're on Mac or Linux, it probably will. Just to show you what the bin width does, if I double this to 20, close that, hit run again, we can see we have 20 bins now that it's doing here. But this is the shape of the distribution of frequencies of the different distance categories across the map. And if I hit 15 and hit run, oops, probably there, it'll pop up again. So now I have 15 categories that it's counting the frequency of. And you can style it a little bit by changing the spacings and stuff or whatever. But you can also save it out to a graphics file right here with the Save button. And again, you can choose any column you want here, and this is a very useful thing. So if I look at the slope value and hit run, now I've got 15 bins of slope across my sites, right? And the frequencies are showing me the distribution of slope at the locations of the tower. So this is the slope values, and this is the frequency of each of them. Okay, I think I've gone on long enough, so I'm going to hit stop on the video now.